Good day to you. This is teacher Leland Alejandro, and we're going to study modeling with periodic functions. Okay, modeling with periodic functions. This will be involving sine functions and cosine functions with real-world situations problems. So we shall see the problem set on the other screen, and we shall start from the first number. Okay, so let us see first the problem set. Okay, here's the problem set, and we shall start from the first number, and this will be about 9. Okay, so there are about 9 problems. Okay, so this will be under modeling with periodic functions. Okay, modeling with periodic functions. All right, so this will include about 9. Yes, 9 questions. All right, so let's start from the first number. Okay, these are lecture examples. Okay, here's the first one. A vuvuzela is a plastic horn about 2 feet long and is used during soccer matches in South Africa. If the sound level of the vuvuzela is 120 decibels from 1 meter away, the sound pressure is 20 pascals. A Pascal function of the sound pressure P in pascals from the sound wave of a vuvuzela as a function of time t in seconds is approximately P of t is equal to 20 sine 1464.612 t. Letter A, identify the amplitude and period of the sound wave. For letter B, use the period of the function to find the frequency of the sound in hertz. Okay, so first, what is vuvuzela? Well, it's an instrument that produces sound. Okay, all right. So we're not going to use the 120 decibels. We're not going to use the 1 meter. The sound pressure 20 obviously is the amplitude. Okay, 20 pascals. Okay, time is in seconds. Okay, time is in seconds, and we have a given equation. All right. Now, let's make use of the given first. Let's make use of the given first. So the given is P of t, and this is equal to 20 sine, okay, open parenthesis 1464.612 t, okay, close parenthesis. Let me elongate that so that it will continue to the right. Okay, there. All right. What you can see here is comparable to our working formula in our discussion about sine and cosine waves, okay, or graphs, okay. So our sine graph looks like y is equal to capital A, that's for the amplitude, and then sine, we have the small b times the quantity x minus h, which is for the horizontal translation, plus k for the vertical translation. All right. In the given, we don't have the h and the k. So this is simply reduced to y is equal to capital A sine bx. Okay. So we have the given a, which is for the amplitude. Okay. And that's 20. You can see it by inspection. Okay. You can see it by inspection from the given P of t. So our amplitude is 20, and this will be in pascals. Yes. So this will be pascals. Also, we have the small b, which is the equivalent number 1464.612. That's the small b. And we can use that to find the period, okay, to find the period. And so this is already the answer for amplitude, okay. This is for the amplitude, okay? That's for letter A. We're asked to get the period, so we will solve for the period. Solve for the period t. And the formula for the period t is equal to 2 times pi over b. That's it. And this is 2 pi over b. And we shall use the numbers, okay? We shall use the numbers here. And so we have here 2 times pi, which is equivalent to 3.14159264, divided by b. Our b is the number 1464.612. There. The number beside the t, okay? All right, and so this will now be just divide, okay? This will be divide, and let me check on that. All right, so this will now be all numbers. We shall compute. This will be t is equal to, let's compute that. This will now be 2 times pi divided by 1464.612. And we have like 4.289999. Let's place that one first. 4.2899999882 times 10 to the negative 3. So this will be raised to the power negative 3 there. So in decimals, this is 0.0429. It's like that, okay? All right, so this will be, of course, in what unit of time? This should be about seconds, yes, according to the worded problem, okay? And we can now abbreviate this. This must be 4.29 rounded times 10 to the negative 3 seconds. This will be, of course, in seconds. You elongate this, and this will have to have a negative 3 here. 10 to the negative 3 there. And so this will be our answer, okay, for the period, okay? This is our answer for the period. So we completed letter A, okay? We have the amplitude, 20 pascals. We have the 4.29 times 10 to the negative 3 seconds. We still have to compute for the frequency, okay? For letter B, use the period of the function to find the frequency. Actually, the frequency is reciprocal of the period. So if we will set our formula, okay, we shall do it over here. Solve for frequency. Solve for frequency f. The formula is f is equal to 1 over t. 1 divided by the period. And so this is f is equal to 1 over this number, 4.29. That's 4.289999882 times 10 to the negative 3. Okay. We have negative 3 there, the exponent. Okay, so we're going to get the reciprocal 1 over that number. So 1 divided by the period. So that will just be 233.1002395. And this will be hertz, okay? The unit of frequency there. And we can round this 233.1, and abbreviate the unit there, okay? And so this will be our final answer there. So this answers A and B, 20 pascals, and then 4.29 times 10 to the negative 3 seconds, and then 233.1 hertz. And we can check the answer from the computer. Okay, so these are the answers right to the center there. So we have 20 pascals, that's correct. We have 4.29 times 10 to the negative 3 seconds. And then we have 233.1 hertz. That's the frequency. So we're done with the first number. Let's continue with the second. Okay, number two. Here's number two. A piano tuner strikes a tuning fork for middle A. So it's a note which has a frequency of 440 hertz at 80 decibels from 1 meter away, or a sound pressure of 0.2 Pascal. What is an equation that represents the sound pressure P in pascals as a function of time t in seconds? Okay, so we're after the equation. What is the equation that represents the sound? Okay, we can get the amplitude from the 0.2 Pascal, okay? We can get the amplitude, it's over here, there. Sound pressure of 0.2 Pascal. We can also get the small b from the frequency, there, okay? Now, 80 decibels will not be used. 1 meter distance will not be used, okay? All right, and so our given, we can only have the amplitude A, which is 0.2 Pascal, there. And we can compute for our B by using the frequency, okay? By using the frequency. So our B is equal to 2 pi f, 2 times pi times f. This is the formula for B, okay? 2 pi f. All right, and so we use the numbers 2 times pi, which is equivalent to 3.14 92654. And then we multiply this by frequency given, that's 440 hertz, okay? And so this will be calculated 2 times pi times 440. So this will be 2 times pi times 440. This is equivalent to 2764.601535. There. Now we can round this to a whole number, 2765, okay? 2765, there. And so we have the amplitude, we have the B. Using the format for the equation, okay, we shall be able to write the equation. All right, so let us write the equation. We have here P of t, this will be equal to the amplitude A sine BT. It's like that, okay? All right, let's put the numbers. P of t is equal to 0.2 sine 2765 t, there. And this will be our answer, okay? There. This will be our equation, all right? So is that all asked in the problem? What is an equation that represents the sound pressure P in pascals as a function of time t in seconds? Okay, so that's it. And we have the equation. Let's find out the answer. Okay, here's the answer, and there, okay? So P of t is 0.2 sine 2765t. That's exactly what we have over here. Okay. All right. So, well, you can express it in terms of pi and the other. Okay. Here. That's 880 pi because that's 2 pi 440. Okay. Used in this equation. If you express your answer in terms of pi, then that would be 2 times 440, which is 880, and then multiply that by pi. Okay, there. So that's why there's another form of answer over there. It's the same thing. Okay, all right. And so we shall move to number 3. Let me clear the screen and let's continue with the next. Number 3 now. Let's have number 3. All right, here's number 3 about paddle wheels. The motion of a point on the outer edge of a riverboat's paddle wheel blade is modeled by h of t is equal to 8 sine pi over 2 times the quantity t minus 1 plus 6. Okay, let us get the given first. Let us make use of the given. Here's what we have. The given equation is h of t, that is equal to 8 times sine, and that's pi over 2. That's pi over 2 and times the quantity t minus 1 plus 6. Okay, we shall elongate it there, so the 6 will be there. And then this has a divide like a fraction. Okay, like that. Okay, if we compare this to our working equation with x and y, then it should look like y is equal to capital A for the amplitude, and then we have the small b times the quantity x minus h is for the horizontal translation plus k for the vertical translation. Now the 8 correspond to our amplitude. The pi over 2 correspond to our b. And the 1 in the given equation, the 1 correspond to our h, the horizontal translation, and the 6 for our k, which is for the vertical translation. Okay, so we can continue with the requirement. Identify the period, midline, amplitude, maximum and minimum values of the graph. So clearly our capital A is the 8, and that will be our amplitude. Okay, so solving for the amplitude, we can now have amplitude A is equal to 8, and this will be in what unit? Feet. Yes, this will be 8 feet. Okay, also comparing it to the second equation, our k is 6. Okay, and that will be our midline. Okay, so we have here midline k, that is our 6 feet there. All right, now next we can compute now for our maximum and minimum. Okay, so maximum and the minimum. So how do we do that? We have a formula for the maximum. All right, we have maximum is equal to midline plus the amplitude. There, okay? So this is our formula, midline plus amplitude. And so maximum is equal to our midline, which is 6 feet, and then we will add the amplitude 8 feet. And so our maximum should be, of course, 14. Yes, that should be 14. So this will be equals 14 feet. There, that's our maximum. Now let's continue with the minimum over here. Let's compute for the minimum. So this will be minimum spelling. Minimum, there. Minimum is equal to the midline minus amplitude. Okay, so this will now be equivalent to midline minus amplitude. There. And so let's abbreviate that. Min is equal to midline. Okay, our midline is 6 minus our amplitude, that's 8. So we will have a negative answer here. Minimum is equal to negative 2 feet. There. Next, we shall determine the period. Okay, we shall determine the period. So we'll just place it at the lower part. Let's see if it will fit there. So we shall compute for the period now. Period t. So solve for period t. Okay, the formula t is equal to pi. We have 2 pi. 2 times pi divided by b. All right, that's our formula. And there must be a divide there. Like that. And then we continue with the numbers. Okay, we have this b equivalent to pi over 2. Okay, remember, this is our b. There. That's our b. Okay, it's pi over 2. Okay. So that's pi over 2. And so we shall use it in our equation for the period t. And so this will now be equals 2 pi. We have 2 times pi divided by our b, which happens to be pi over 2. So this is divided by pi over 2. It's like this. And so what do we get from our division? The pi and the pi cancels out, and we'll be having 2 divided by 1/2. Okay, so if we're going to write this, this will continue with something like 2, because the pi and the pi cancels out, we will have 2 divided by 1/2, like that, like this. Okay, and so this will now be, of course, how much? 2 divided by 1/2 is 4. Okay, so our answer should be 4 unit of time, which is seconds. Okay, so our t is 4 seconds. There, that's it. Okay, and we have all the requirements. First, you have to determine the period. And there's the period. That's the first one to ask. First one asked in the problem. So it's that's 4 seconds. Okay, the first item, but we answered it last. Okay, but it's just that we can readily see the other things there. Okay, so that's for the period, and we have the midline. All right, and then we also have the amplitude. Okay, we also have the maximum over here. We also have the minimum over there. Now, in graphing this, if you're going to set up with graphs, you have this, your h, you can see this like your h, and this is the level 6, and this is the level 0 there. This is the level 0. It's something like this. This is the level 6 there. Now, our graph swings along the 6, okay, because that's the midline, okay? That means our sine graph is doing like this, there. It's like that, okay? So the lowest part is lower than the 0 line, okay? That means that's the -2 there. there. And then the highest peak is from the level 6, it swings upward. That means plus the magnitude of the amplitude 8. That means 6 plus 8. So this level is 14 there. So that's why we know our maximum is 14 feet, and the lowest part is below the 0 level. So it's a negative, okay? That's why we have negative 2 feet. So our midline is actually the vertical translated level, okay? Not in the 0. It's swinging at the level 6. So it goes up and down at that midline. So that's why we have our midline at 6 feet, okay? So this is actually the height axis, and this is the time axis, the 0, okay? So there. All right, and so these are the answers, and we can verify. Let's see the answers. Okay, at the center of the screen, you can see it blinking there. I will encircle it and close it. The answers are period 4 seconds, midline 6 feet, amplitude is 8 feet, maximum is 14, minimum is -2. That's below the surface, okay? Because that's submerged 2 feet lower, okay? 2 feet below the surface of the water. You can take the surface of the water as the 0, okay? And then the center of the wheel, the level 6, okay? The level 6, because that's a wheel, okay? A part of the edge goes upward and then downward, okay? Upward and then downward. Remember, it's a periodic function. So the lowest part is lower than the water level. It's lower by 2 feet. And then it swings upward. That's 14 feet, okay? Above the water level, okay? All right. Now, where's the 6, the level 6? That's actually the center of the wheel, okay? Connected to the ship or the boat, yes, the river boat. All right, so this will be the worded problem number 3, okay? I hope you were able to figure out the problem. So number 4, let's continue with our fourth. Let me clear the screen. Here's number 4. This is something about the amusement parks. The motion of a gondola car on the Ferris wheel at Navy Pier in Chicago can be modeled by h of t is equal to 70 sine 2 pi over 7 times the quantity t minus 1.75 plus 80, where h is the height in feet and t is in the time in minutes. Identify the period, midline, amplitude, maximum, and minimum values of the graph. Okay, this is similar to all the other problems. Okay, let's write the given first. Okay, from the given, this is the given equation. We have h of t is equal to 70 times sine 2 pi. That's 2 pi over 7. Okay, so this is over 7 right here. This continues with the parentheses t minus, let's elongate this. Okay, that's t minus 1.75. That's for horizontal translation, plus at. That will be for the vertical translation. And this 2 pi over 7, this is our b. So if we compare this with our equation in terms of x and y, this will be y is equal to capital A sine small b times the quantity x minus h, close parentheses, plus k. And you can compare the numbers, okay? This means A is equal to 70 there. And our small b Our small b is 2 pi over 7. So that means 2 times pi over 7 there with a fraction like that. That's our b. Okay, that's our b. Okay, that's beside the parentheses and the variable t. In our equation, that's beside the variable x at the parentheses. So the h, we also have the h for the horizontal translation. H is equal to 1.75. And finally, we have the midline, the vertical translation k. That will be for the 80 there. And so we can use all this to find all the requirements. Okay. All right. So first we can identify the 70. That's our amplitude. Okay. The A. So we have amplitude. Amplitude A is equal to 70. And this must be in feet. There. So we have our first answer. Okay. This is our amplitude. We can also determine right away the midline. The midline is the added number 80. Okay. So we can put that somewhere at the left side of the screen. Okay. Left side of the screen. So we have midline. Midline K is equal to 80. This is also 80 feet there. Okay. All right. Next, we can compute now the maximum and the minimum. Okay. So this will now be max for the maximum. There. Okay, for max, this is equal to midline plus amplitude. Okay. And the numbers are, our midline is 80 added to amplitude, which is 70. And so we have 150, okay? Our max is equal to 150 feet. Next is for the minimum, okay? So we have for the minimum, okay? This will be minimum is equal to midline minus, okay? Minus the amplitude there. And so we have minimum is equal to our midline, which is 80, minus our amplitude 70, and that provides us with a value 10, okay? So this will just be equivalent to 10 feet. That's 80 minus 70. And so we have the max, and we have the min there. What else do we need? The period, okay, the period. All right, so we shall use the left side of the screen. Okay, we shall determine the period. So this is for the period t. And the formula for period t is equal to 2 pi over b, okay? There, 2 pi divided by b. This is our formula. And so we will continue with the numbers. This is equal to 2 pi So we have 2 and then pi divided by our b. Our b is 2 pi over 7, okay? 2 pi over 7, right here at the center. So this will be 2 pi divided by 2 pi over 7. So this is 2 pi over 7. There. Okay. All right. And so the 2 pi cancels out with the 2 pi. We will have 1 over 1 over 7. Okay. And so this will now be 1 divided by 1 over 7. It's like this, because the 2 pi cancels out with the 2 pi. And so what is left in the expression will be just 1 and 1 over 7, which gives us 7, the final answer. The final answer is just 7 unit of time. And our unit of time here is minutes, okay? So this will be 7 minutes there. And so this is our answer there. Okay, so 7 minutes, that should be it. Okay, and let's verify the requirement. Let's verify. Okay, there. So these are the answers from the computer's database. Our answer is 7 minutes for the period. Midline is 80. Amplitude is 70. Our maximum is 150, correct? Minimum 10 feet, correct? Yeah. Okay, so you can actually get all the answers from the given equation, okay? So when you're solving problems like this, just remember these formulas to get the period, okay? Remember this formula over here. Remember that formula over there? That's how to determine the period, okay? Okay, all our answers are correct. We shall now move to number 5. Let me clear the screen. And then the answers. We shall now proceed to number 5. Here's number 5. Amusement parks. The height h in feet of a car on a different Ferris wheel can be modeled by the equation. Okay, we have another equation here. H of t is equal to negative 16 cosine pi over 45t plus 24. So the equation has all the a, the b, and the k. We don't have the h here, the horizontal translation. So let's write the given first. So we start from the given. We have the function h of t. This is equal to negative 16 cosine. And then we have pi over 45. And then t plus 24. There. Let me extend that. Okay. And this will have a divide there. Pi over 45. Okay, there. All right. And so we can identify this using our own equation, x and y. Okay. We have y is equals capital A for the amplitude, cosine small b times the quantity x minus h plus k. In this case, we don't have the h. It's a zero horizontal translation. So this will be reduced to y is equal to capital A cosine bx plus k there. And so we can readily see our amplitude, which is the negative 16. Now, we don't have a negative amplitude. We will have to get the absolute. So for amplitude, our A is equal to absolute of negative 16, which is just 16. There, okay? And so amplitude A must be a positive 16 feet. Yes, there. Okay, using now the K, which corresponds to the 24. and that will be our midline. Okay, that will be our midline. So midline will be midline K by inspection. That's the 24 feet there. Now we're ready to get our maximum and minimum over here. Solve for max. Okay, for maximum there. So max is equal to midline plus the amplitude. And so we have max equals midline, that's 24. We're going to add the amplitude 16. Remember, it's a positive 16, and max is computed 40. So this will be 40 feet there. Next, we will be computing for the minimum, okay? So we have to have the solve for minimum there. We have minimum is equal to midline minus amplitude there. And so minimum is equal to our midline, which is 24. We will subtract the amplitude 16. And that results to a minimum of 8 feet there. It's 24 minus 16. So that is 8 feet. So we already have the answers: amplitude 16, midline 24, maximum of 40 feet, minimum of 8 feet. We need to get the period, okay? All right, using the same formula for the period, okay? At the left side of the screen, solve for the period t. The formula is 2 pi over b. So it's 2 times pi over b. And this is our formula, 2 pi over b. And we shall get the numbers from the equation. And so in the equation, we have to start with the 2 pi. Okay, we have 2 times pi divided by our b. Our b is the number beside the t, which is pi over 45. That's our b. So this is divided by pi over 45, like that, okay? And so this will be our expression here, 2 pi divided by pi over 45. Notice that pi and pi cancels out, okay? That cancels out, and so the equation becomes just 2 over 1 over 45. So this will be 2 divided by 1 over 45. Okay, it's like this, 2 divided by 1 over 45. The pi and the pi cancels out. And so 2 divided by 145, that's 90, okay? So our period is 90. So t is equal to 90 with a unit of seconds there. So this must be our period there. Let's check and verify the answers. Let us see the answers for number 5. Okay, there at the center of the screen. Okay. These are the answers. 90 seconds, check. Midline, 24 feet, check. Amplitude 16, check. Maximum of 40, minimum of 8. So we're done with the answers. Let's continue with number 6. Okay, here's number 6. Historic technology. Water turns a water wheel at an old mill. the water comes in at the top of the wheel through a wooden chute. The function h of t is equal to 15 cosine pi over 5t plus 20 models the height h in feet above the stream into which the water empties of a point on the wheel where t is the time in seconds. Identify the period, midline, amplitude, maximum, and minimum values of its graph. Okay. All right. So the height is in unit of feet. The time is in unit of seconds. Okay. All right. And so let's start with the given. Start with the given again. And we have h of t is equal to 15. That looks like the amplitude already. Cosine pi over 5. So pi, I will just write the word pi over 5. Okay, we don't have a Greek letter in my keyboard, so that's pi over 5, and then continue with the variable t plus 20. 20 is the midline. Okay, that's the vertical translation. Okay, this will have a divide symbol there. That's pi over 5. There. Now comparing this to our x and y equation, y is equal to capital A for the amplitude, cosine small b x minus h. In this case, we don't have the horizontal h, so this will be reduced to something like y is equal to capital A cosine bx plus k. There. And so the variables x correspond to t. The k is for the 20, the b is for the pi over 5, the a is for the 15. And so if we're going to identify it, comparing with our equation, okay, our a is equal to 15. Our small b, our b is pi over 5, like that. There. Also, our k is the 20. Okay. Okay. So our k is the 20 there. And so right away, we know the answers. Our A is the amplitude, okay? And we can readily see that, and we can readily get the amplitude. Amplitude is equal to 15, and this must be feet. Also, our midline K. Midline is the 20, okay? And this will be 20 feet there. All right, what else? We can now compute our maximum and minimum. Compute for the maximum and minimum. All right, we shall use the right side of the screen. Okay, for our max. Okay, maximum is equal to midline plus the amplitude. There. And so we have max is equal to midline, which is 20. We will add the amplitude of 15, and we get a 35. Maximum is equal to 35 feet. There. And so we'll continue with the minimum, okay? We shall continue with the minimum. Okay, for the minimum, this is equal to the midline minus the amplitude. Okay, we're going to subtract the amplitude this time. So we have minimum is equal to 20 minus the 15, and we will get 5 feet. There. And so we have our amplitude We have our midline. We have our maximum. We have our minimum. Okay, just one more. We're asked to get the period, okay? All right, we're asked to get the period. And so we shall compute for the period over here at the left side of the screen, lower left. So this will be period T. And the formula for the period is 2 pi over B. So this is the formula, 2 pi over B. And so we shall make use of our numbers. This is equals 2 pi divided by our B. What is our B? All right, over here. Our B is over there. It's pi over 5. So this is 2 pi divided by B. That means 2 pi over 5. So we shall have here pi over 5, pi over 5. And this is to be divided. All right, so this is 2 pi divided by pi over 5. Notice that the pi and the pi cancels out, and this will be reduced to 2 divided by 1/5. This will just be equal to 2 divided by 1/5, like that. Because the pi and the pi cancels out, the expression is reduced to 2 over 1/5, which results to 10, okay? And this will be in seconds. So 10 seconds is our answer for the period. So we have 10 seconds for our answer for the period, okay? So this is now 10 seconds. All right, let's find out the answer from the computer. Okay, at the center of the screen, you have the answers. Period is 10 seconds, check. Midline is 20, okay, that's correct. And then amplitude is 15, maximum is 35, minimum is 5 feet. Okay, so they're all correct. We shall continue with number 7. Let me clear the screen and continue with number 7. Okay, here's number 7. Okay, here's number 7. A toy is suspended 36 inches above the floor on a spring. A child reaches up and pulls the toy and releases it. So when the child pulls it downward, it oscillates like that, okay, forming a wave, okay? All right, so the function h of t is equal to 10 sine pi x minus 0.5 plus 36. Models the toy's height h in inches above the floor after t seconds. Identify the period, midline, amplitude, maximum, and minimum values of the graph. Okay, so let us start with the given first. Let us start with the given first. We have h of t, and this is equal to 10 times sine, and that's pi. Okay, so instead of the Greek letter pi, I'll just write the word pi. All right, and this will now be x minus 0.5, and let's elongate that so it will continue to the right. That's x minus 0.5 plus 36. Okay, this time it's complete. If we compare this with our x and y equation, this is y is equal to capital A sine b x minus h plus k, and then compare each letter. We have our amplitude A. Amplitude A must be 10, okay, there. And the unit will be inches. There. Also, we can readily see our B, okay? Our B. Our B correspond to pi, okay? There. Also, our H is 0.5. We are not going to use that, but we can identify the given. H is equal to 0.5. Now, the added K correspond to that there's the 6, okay? And that corresponds to the midline. So we can now have the midline K, and this is 36, also in inches there. Okay, so we have amplitude, we have midline. We can solve for the maximum and minimum values of the graph. Okay, so we shall use the right side of the screen, solve for max. Okay, so maximum, we have max is equal to a midline plus the amplitude, okay, amplitude there. Okay, so max is equal to our midline value, which is 36. We're going to add the amplitude of 10. And this gives us maximum value of 46. Also in inches. Next, we compute for the minimum value, okay? And this will now be minimum we have min is equal to midline minus, okay? We're going to subtract the amplitude. So if you're about to get the minimum, it's midline minus amplitude. If you're about to get the maximum, it's midline plus amplitude, okay? Because minimum, you're going to find the lowest part. So we have minimum is equal to our midline 36. We subtract the amplitude 10, and we get something like 26 inches. There. And then finally, we shall compute the period, okay? And we shall use the left side of the screen for the period, okay? So for the period T, the same formula, T is equal to 2 pi over B. The same formula, 2 pi over B. And we shall continue with numbers given. We have 2 times pi divided by B. Our B is another pi, yes? So this will be like this. And so this is 2 pi divided by pi, which is reduced to just 2. And our final answer for the period is 2. And time is in seconds. So this will be in seconds there. Okay, so these are the answers. The period is 2 seconds. We have the midline 36, amplitude of 10, maximum of 46, minimum of 26. There. All right, so we can check and verify from the computer's database. Okay, there. At the center of the screen, you can see the answers. Period is 2 seconds, check. Amplitude is 10 inches, check. Midline is 36, check. Maximum is 46, minimum is 26. Yeah. All right, so that completes our number 7. Let's proceed to the next, number 8. This is number 8. All right. It has something to do with high tide. Okay. All right. At a location of a pier on the main coastline, the function d of t is equal to 4.36 cosine 0.499t plus 8.79. models the depth d in feet of the water t hours after the first high tide during the first quarter moon. Identify the amplitude, period, and midline. Okay, so we shall begin with the given. Okay, let's start with the given first. The given, we have d of t. Okay, and this models the depth d in feet. Okay, so this has something to do with how deep is the water. All right, and this is equal to 4.36 cosine 0.499 t. Let's stretch that so it will continue to the right side, plus 8.79 there. Okay, so let's compare this to our working equation with x and y. We have y is the dependent variable. We have capital A for the amplitude, cosine, okay, cosine B times the quantity x minus h plus k. All right, this is our equation in our discussion of periodic functions. Our capital A is for amplitude, our K is for the midline, the vertical translation. Our H is for the phase shift, horizontal. Our B is the number we use to find the period and the frequency. All right, and so if we compare the numbers, we don't have the H. H happens to be 0 in the given, okay? There is no minus, okay, from the T, or yes, and yes, and we only have a number added, which is not included in the parentheses. That's the vertical, okay? All right, so our equation will be reduced to the numbers A, B, and K, so that we can identify right away our amplitude A, which is the 4.36. 4.36, and this will be a unit of feet, okay? This is our amplitude. Next, we can have our B, okay? Our B is 0.499, 0.499. That's the number coefficient to the variable t, okay? So that happens to be the small b. Now the midline is readily obtained here, okay? Midline k. Midline k is to 8.79. 8.79 also in feet. And we're now ready to determine the period, okay? The maximum and minimum is not asked here, so we can compute for the period. All right, so we can make use of the formula for the period, the same formula. So for the period t, so we have t is equal to 2 pi over b. There. And so this is the same formula. And we shall use the value of the pi and the b. So we have t is equal to 2 times the quantity pi. All right, pi is equivalent to 3.14. 15.92654, yes. And then we shall divide this by the number b. In this case, it's 0.499. It's 0.499. This will be our divisor. And these are pure numbers. We shall compute and determine the answer for the period in, this will be hours, okay? Okay, this will be hours over here. All right, so we shall compute first. So this is equals, how much is that? That's 2 times pi divided by 0.499. So that's 2 times pi divided by 0.499, we get something like 12.59. 12.59, 155,372. And this will be rounded. We can round this to 12.59. And this will be hours. Yes. Yes. Okay. All right. So that's for the period. And we have the answers. We have identified the amplitude, the period. Okay. This is the period, 12.59 hours. How about the midline? The midline is right here, 8.79 feet. The added number to the equation, okay? That can be obtained by inspection, okay? So that's 8.79. All right, let us see the answers. So this will now be, okay, amplitude 4.36, period is 12.59 hours, midline is 8.79 feet, okay? That goes to our number 8. All right, I hope you were able to figure out how to get the answers from the given equations, okay? From the first question up to number 8. Now, let's proceed to our number 9. Okay, so let me continue with number 9. Here's number 9. The heights of astronomical tides are affected by the moon phase, a function that models the depth d of the water in feet and period t in hours at the location of a pier on the main coastline after the first low tide during a new moon is d of t is equal to 6.31 sine 0.503 times the quantity t minus 3.13 plus 8.75. All right, so it looks like we have here the equation. Okay, and let's write the equation first. So we have our given equation, and we have d of t is equal to 6.31 sine, and then 0.503 times the quantity t minus 3.13. Let's stretch that. This will be 3.13 close parenthesis plus 8.75. Okay, this is our given, and we can compare this to our working equation in our x and y sinusoidal equation. Y is equal to capital A sine, and then we have b times the quantity x minus horizontal translation plus k vertical translation. And we seem to have all the numbers, okay? From the given equation and comparing it to our equation, we have amplitude A. Amplitude A must be the 6.31. And unit of, that should be a unit of feet. Function that models the depth in feet, yes. So this will be in feet. All right, what else? We can see the value for B. The value for B must be corresponding to 0.503. 0.503 there, okay? All right, what else? We also have the H. We have the H, the horizontal translation for phase shift, that's 3.13 there. Also, we have now the 8.75, that's the added number, that must be the midline. The midline K is equal to 8.75. This must be also in feet. Okay? All right, we can readily solve for maximum and minimum for the waveform, maximum and minimum, but it's not required. Instead, we are required to get the period, okay, period of the function. All right, so we can do that at the right side, okay. We'll just do it over here. We're asked to get the period t. So solve for the period t. And the formula is the same formula, 2 pi over b. And so we will put a divide symbol there. 2 times pi divided by b. That continues with the values that we have. This is now equals, okay, the numbers are given. So we will have to multiply 2 by the value of pi, 3.1415.92654. And this will be divided by our b, which is given here. Okay, it is given here as 0.503. 0.503, yes. And this will be just computation. This will be the product of 2 and the pi divided by 0.503. How much is that? This will be 2 times pi and then we divide this by 0.503. And this calculates to 12.49. So this is 12.49142208. And the time is, this must be in hours, okay? Yes, it's right here in the wordings. It's right here. So this will be in hours. Now, the unit of depth is in feet there, okay? So our period or our time is rounded to 12.49 hours there, and that's it, all right? We're asked to get 3 items only, namely the amplitude, the period, and the midline, yes, there. So the amplitude and midline are so easy to see if it's present in the equation, okay? But the period has to be computed. All right, and so these are the answers. We shall check and verify the answers. All right, we have here 6.31 feet for the amplitude. Period is 12.49 hours. So these are both correct. And for the midline is 8.75 feet, okay? Yeah, so as I was saying, it's so easy to get the amplitude and midline from the given equation, okay? So you only need to memorize the formula for the period over here, there. All right, so that concludes our worded problems for periodic functions, okay? Modeling with periodic functions. So this will be all for now, and see you later for other topics. God bless.